I want you to see this. So this is the 203 autopsies. 87 were accidents. 72 were homicides. 36 were suicides. And in that group, 25 of subjects carry an ApoE4. If you notice, the higher advanced levels of Alzheimer's were present in the ApoE4 carriers and in the homicide victims. And we'll discuss that in a few seconds. This is something I want you to take a look carefully. Tau, the hyperphosphorylated tau, is the major marker of Alzheimer's disease for our cases exposed to high levels of air pollution. And this is tau per decades. This is age 0 to 20, and the majority of these individuals in green are in the pre-triangle stages 1A and 1B, and this is age 21 to 40. And you can see the differences between the first 2 decades of life and the decades 3rd and 4th. So what we're seeing here is that the hallmarks of Alzheimer's disease starts very early. In fact, the youngest member of this study was an 11-month-old boy, and he already had all the hallmarks of Alzheimer's disease. The only person in this entire group of 203 cases that did not have any markers of Alzheimer's was a 22-year-old subject with a specific mutation for toll-like receptor 4 that protect him from the disease. One thing is important in this study. Is there any risk of suicide for people who live in big polluted cities? And if there is, what is the reason for that? And we were able to determine in this study that the ApoE4 carriers have 4.92 times higher suicide risk and 23.6 times higher odds of reaching a high level of neurofibrillary degeneration versus the APO3 carriers, which by definition don't have a high risk of Alzheimer's disease. Now, these are some of the pictures for the histochemistry and the electron microscopy in these subjects. And pathology has one advantage, you should know. We have the block, we have the paraffin block. We can cut from that block 1,000 slides so people can see the lesion over and over and over, and it stays there, doesn't go anywhere. So the first thing we realized that was the impact of air pollution is extraordinarily important at the level of the blood vessels in the brain. And this is the neurovascular unit and the significant damage to that structure. And then we can see the tau, the positive neurites in these very young babies, and the amyloid, which will be the 2 major hallmarks for Alzheimer's disease. This is the first decade of life. When we go to the second decade of life, the pathology is overwhelming. You see hyperphosphorylated tau in cortical regions, frontal, temporal. You see big tangles in different levels. This is cervical. This is in brainstem. And you certainly see a significant number of subjects with amyloid plaques. And those amyloid plaques could be very extensive, as in one case in an 11-year-old boy, and it could be to the degree that we have clear-cut amyloid angiopathies. When we see the targets of air pollution, one very clear target is the olfactory bulb. We inhale the air we inhale full of particles and full of neurotoxins, enters your nose, goes into the upper turbinate, and from there directly to the olfactory bulb. No stops. The access of those neurotoxins is direct. We have been able to document that from the neuropathological point of view and also from the fact that our children have significant olfactory deficits. Let's see what's in the olfactory bulb. The same very major vascular pathology is seen, and then when we take a look by electron microscopy, there are changes in the blood vessels. And I want to call your attention to the fact that we can pick up nanoparticles, those tiny particles I talked to you at the beginning of the talk, less than 100 nanometers, in the axons, in the blood vessels, in the red blood cells, everywhere. So, what do we have here? We have the identification of clear-cut hallmarks of Alzheimer's disease very early in these children, from stages 1 and 2, amyloid phases 1 and 2, and then we can also pick up hyperphosphorylated tau in substantia nigra, which, by the way, is the target of Parkinson's disease, in the auditory, oculomotor, trigeminal, and autonomic systems as early as the second decade. By the third or fourth decade, 24.8% of individuals already have stages of neurofibrillary tangles 3 and 5. And this is what we see in a 30-year-old individual. So, tau all over the place, big plaques, big tangles, and extensive areas involved by amyloid. Now, this is a diagram of a brain. I want you to pay attention to the green structure here. This is the brainstem. And what we did in 186 cases, we cut sections, as many as 30 sections through the entire brainstem, and then we wanted to define if other markers of neurodegenerative diseases were present in these individuals. And we were concerned about the Alzheimer's hallmarks, as I mentioned before, hyperphosphorylated tau and beta amyloid, but also Parkinson's disease. And the marker of Parkinson's disease is alpha-synuclein. And there is a significant number of cases of neurodegeneration associated with specific other diseases. And that will be the frontotemporal dementia and the amyotrophic lateral sclerosis, Lou Gehrig's disease. And the marker for these two entities is called TDP43. So these 186 Mexico City residents were aged 27.2 plus minus 11.8. Now, notice there is no one single individual in these reviews and cases that is older than 41. We did not include anybody older than 41 in our studies. And to no surprise, because in reality we were not surprised about our findings, we found the 4 overwhelming aberrant proteins located in the brainstem of these 186 subjects. And I put in red overlap. And I want you to be aware there is an overlap of pathology. Alzheimer's with Parkinson's, Parkinson's with the marker of TDP43, and the mixtures of the overlap. So, how many of those cases, how many of the 186 cases had the hallmarks of Alzheimer's? 99.5%. 23% of subjects had the hallmarks of Parkinson's disease, and 18% had the hallmarks of frontotemporal dementia and ALS. So, we will expect there is a common denominator for these pathologies. Because remember, these subjects don't have hypertension, didn't have heart disease, didn't have a stroke, didn't have kidney damage. They were young. They were walking on the street. They had no disease whatsoever. So a common denominator, I think, could be nanoparticles.